Hi everybody, as promised I'm going to post this Cosmoclimatology and Galactic Cycles, a very incomplete quick guide to the riddle part 1. Unfortunately, when we had the get together the other week, somehow Skype decided to evict me and I was unable to get back on to kind of get through that presentation. So in no short order, here it is. And before we get started though, a quick thanks to the kind folks that keep the plugs plugged in and the lights on. So have you guys got the disaster prediction app yet? I sure have, and I think it's great. It's very easy to use and has a lot of nice functions to it, including the social media one. That's great, especially if you're on Twitter. If you ever want to know when imminent peril may be coming your way, this is the app just for you. It has earthquake alert maps, disaster risk, and you can set your own notifications and alerts as you see fit. So for $2.99 on Google or on apps for iPad or your iPhone, it's an ideal app to have, and it only costs $2.99, which is gosh darn cheap. So don't forget to download that today. All right, everyone, if you would kindly look up the thread a bit, you'll see some items that I posted, including this one. As you will see, the sun entered the local bubble roughly about 1 million years ago. And essentially, the sun in the heliosphere is moving through the local interstellar gas cloud approximately into the direction of Scorpio with a speed of about 25 kilometers a second, roughly. As a result, it kind of would feel like as if you were in a convertible with the top down. The interstellar wind with that speed is blowing through our planetary system. Now, let's talk about galactic ecology for a second. Understanding the structure of the local interstellar medium is important because it interacts with our heliosphere. It's kind of like Goldilocks. If the interstellar medium is too hot, that could potentially cause a problem with our heliosphere, and if it's too cold, it could really cause a problem with our heliosphere and the planets therein. We want something that's just right, and luckily for the last 1 million years or so, we've been on that path of just right. Now, it's believed that the sun is located barely inside the local interstellar cloud. Currently, it is thought that the motion of the sun through space will take the heliosphere outside of our local interstellar cloud and into either 1 of 3 places. And this transition, by the way, will occur in, again, less than 4,000 years and perhaps a lot less, maybe tomorrow. And now, just again, an idea to digress for a second. Several years ago, they were saying that this transition would occur in the next 12,000 years. And the most recent assessment was that it would take place in maybe 0 to 4,000 years. And although I haven't seen it officially published out there yet, I think the sense is that it will be between now and perhaps 150 years or 50 to 100 years, somewhere in there. In any event, the heliosphere will go outside the local interstellar cloud and into either basically 1 of 3 places. It will either go into that G cloud. There may be an interface between the local interstellar cloud and the G cloud that it could go into, or there may be highly ionized gas that may be between the clouds that it would enter into, that it is thought may be a higher temperature. All right, so let's talk about solar encounters with interstellar clouds. Surely this is axiomatic, but how do we know that on Earth? Well, one of the things we can do is look at radionucleotides such as beryllium-10 and carbon-14 in geologic ice core records. We know that as we travel through space, the abundances and ionization states of elements in the interstellar cloud determine what the anomalous cosmic rays and pickup ions will be. So eventually that filters through to our planet, and we can find that in our ice core records. But aside from that, how does this affect us? Another thing that it can do, besides depositing radionucleotides on our planet, is it can potentially shrink our inner heliosphere. There's been a lot of models run. For example, one of the Sentinel articles discussed is by Gary Zank, who wrote an article on modeling the interstellar medium vis-a-vis the solar winds in 1999. That is definitely good background reading, should you need it. When we talk about the density of outer space, what are we talking about? Well, for example, hydrogen, density of hydrogen in interstellar space is on the average of about 1 atom per cubic centimeter. It can go as low as 0.1 atom per cubic centimeter, and it can go possibly as high as 1,000 atoms per cubic centimeter near the galactic core. So what does it mean if we hit a denser interstellar cloud? Well, for example, we have modeling that gives us an idea of what that could be. One of the concepts that's come up through a guy named Muller in 2006, he measured the location of the termination shock and heliopause, considered the wide range of interstellar densities and temperatures and the flow velocities near the heliosphere, and came up with the concept that if the passage of the heliosphere through a cloud with neutral hydrogen density of 11 cubic centimeters rather than the present value of about 0.2 cubic centimeters, that would shrink the termination shock from about 90 AU in the upwind direction to only about 14 AU. So that would be very dramatic. We'd probably have a couple bad hair days, that's for sure. So what would be some of the impacts that we would have? Well, there would be a sharp rise in cosmic radiation. That would be a big problem. But like I said, that's all theoretical. So what are we really looking at? Well, I think that the biggest problem that we have right now, potentially, is that at present speeds, we can expect to collide with a denser cloud that is basically approximately the range. All right, sorry about that. I had to stop and take a call. All right, so where are we at right now? Well, there's one nearby cloud that we're looking at through a couple of telescopes, including the Hubble. One of them is less than 1 trillion miles away, so that's just roughly about 250 times the distance between Earth and Pluto. We think that the cloud is relatively dense, and obviously that would be potentially destructive. And at present speeds, we can expect to bump into that cloud in roughly, probably less than 2,500 years. That's assuming that with the current technology that we have, that we're measuring that correctly. The other issue is there is likely, there's certainly evidence, and we'll talk about that, of smaller, denser wisps of denser clouds between our planet. All right, sorry about that. I got interrupted again. All right, so essentially what would happen is the leading edge of the heliosphere, if it collided into a denser cloud, it would begin accumulating like this large wall of stuff. And what would happen is eventually all this interstellar dust would accumulate with hydrogen. And eventually the solar winds would be unable to hold that back. So in a decade, a hydrogen wall, now thought to be 4 to 5 times past Pluto, would come in and crowd in between the orbits of Saturn and Uranus. All right, well, why do we care about all this? We know from the past that it's very likely that our heliosphere was compressed, and there are some theories that say that this potentially led to ice ages on our planet. Obviously, that's not conclusive, but that is one fairly well understood theory. But what if this happened tomorrow? What could we expect? Well, one of the things we could expect would be an increase in cancer rates. The heliosphere would be unable to protect us from as many cosmic rays as it does. And one of the obvious things that would happen is it would wreak havoc on our electronics of satellites, and it would threaten our astronauts, obviously. And it would smack us with a whole bunch of gamma rays, X-rays, etc., and cause us substantial increases in cancer. Would something like this be survivable? Well, we're not sure. I mean, obviously, we have passed through these many times, and we will pass through them many times again. Let's talk about Earth for a second. And first, though, I think we'll end on this segment on this part, and then with suspicious observers' permission, of course, hopefully I'll be able to post 2 more segments, one of them on galactic cycles and one of them on the current galactic condition in terms of the scintillation that is being seen out there as evidence of either colliding clouds that are not really agreeing with each other, kind of bickering, but that doesn't actually help us out, or possible evidence of these colder wisps of clouds as we approach the end of the local interstellar cloud. I think the other section then will be on grand galactic cycles and how they've affected our planet in the past and how they will affect it in the future. So anyway, getting back to this is actually a graph from 1978 where they were looking at the implications of running into a denser cloud for a protracted period of time. Probably what would happen is that the ionospheric F region would largely just completely disappear. The water vapor content of the middle atmosphere would be greatly enhanced, and this would reduce our ozone concentrations dramatically. Ultimately, the climate on our planet would become much, much colder, and it would eventually result in radiative cooling at the surface and be sufficient to trigger an ice age. So on that cheerful note, I will say goodbye for the time being. Just so you guys know, anything that is said in this segment may or may not be the opinion of those who run suspicious observers, and the disclaimer goes to just to say that they may or may not share these opinions, but they are strictly my own, and I will also post the research that backs this segment up very shortly. I just wanted to get it out because I felt bad that Skype kicked me off. So that is it for now, and I appreciate your time. And again, if you have not supported Suspicious Observers yet, please do so. They have not asked me to do this. I'm just simply saying, hey, they keep the lights on, so they definitely deserve a generous contribution on your part. So please do so. All right, until next time.